Hello guys, we are going to discuss about question number 8 and question number 9. These are related to Boolean algebra, but question number 8 is related to duality, the principle of duality, and question number 9 is related to the value of the Boolean algebra. These are two different concepts. Okay, first of all, we'll understand about what is this duality means. Duality means you are actually swapping the operations operations without changing the variables. We are not changing the variables, but we are swapping the operations. How do we swap? If there is and, you can swap it by or. If there is or, you can swap it by and. If there is 1, you can swap it by 0. If there is 0, you can swap it by 1. And we are not changing x bar or x or y or z. Okay, that means we are not changing the complements. We are not changing any of the variables, and we are not changing the brackets as well. If there is a bracket already available by grouping, you want to keep it as that way. Okay, that is just as that way. Okay, now we'll see question how do we solve this question number 8. Okay, only thing you want to swap the things, but you want to go according to the operator precedence. That means there is a priority order of Boolean algebra. The first preference is given for the brackets, then for the complement, then for and the last is for or. Okay, but you want to first arrange the equation for swapping. I'll take this question number 8.1, that is x dot 1 plus yz. Okay, you can change now according to this way. You can keep the things according to operator precedence. We'll first inside bracket we'll put x bar here dot 1 plus, and here we can put inside bracket, we can put y. Since it is dot, you can put plus, because here is and is available. You can replace it by the o. O means plus. Okay, then what you want to do, after that you want to go for the complement. The complement is there here, and so the xy is there, and after that now you can say the dot is there because it is and. Okay, and you can replace it by what? Plus. And now here is 1 is there, you can replace it by 0. Okay, x plus 0 and plus y plus z. Okay, but this plus, what is that? That is the last thing you want to do. It is o, right? So what do you want to do? X bar plus 0, and this plus you can put a dot, and here y plus z. This is the last answer, x plus 0, y plus z. Oh, you don't want to actually put this dot because we know that it is the multiplication, or this is the dot product, and it is the end. X plus 0 dot y plus z. That is the first answer. We'll take it to the second one of that one. Second it is x bar dot yz plus xyz xyz xy bar z plus xy bar y z bar, x y z bar. Okay, now since the complement is the first preference and there is no ones or zeros, so only the thing is you want to see which is getting the preference, is that the or and, so in that case it is and. Okay, so you can just put and is x bar, you can put plus y plus z. Okay, you can put like that way, and plus here here also x plus y plus z plus here x plus y bar plus z plus here x plus y plus z bar, and after that you can change this plus value to dot. So x bar plus y plus z dot x plus y plus z dot x plus y bar plus z dot x dot x plus y plus z bar. This is the answer. Okay, in that way you can see that's the answer we are getting here. Okay, so that is simply the duality. Okay, why we need this duality? What is the purpose of having this duality? It is we can simply say that buy one get one free. That means if you want to prove some kind of concept mathematical thing, okay, by using this duality, if you prove some kind of thing, and if you got some answer for one particular case, and duality also, if you get some answer for one kind of thing, and by changing the operations and by swapping the thing, if they ask you to prove for the duality thing, you can just say that since this is true and this is the duality of that one, and it should be valid. Okay, you don't want to prove again. Okay, if you can prove one particular case, that will be enough. Using the duality principle, the other one will be true. That is the advantage of the duality. Right, now we'll move to the question number 9. Question number 9, it is asking us to find the values. Find the values. Okay, here in the previous case we got the answers by the variables, but here you can get the answers by values. Okay, the only thing is here what we want to do is here you know that 0 bar equals to 1, 1 bar equals to 0. Okay, that thing you want to consider here. Okay, and you know that 1 plus 1, it is equals to 1. Okay, and so that means if one, this is O, right? In O, 1 is true, the answer is true, and if it is AND, it has to be both has to be true, therefore 1 dot 0 equals 0. Okay, so then we'll go to solve this one. Okay, then 1 plus 1 and 1 plus 0 bar. Okay, now we are not going to swap the things. Okay, what we are going to find the values. Okay, when getting the values, first start with the boolean. Here 1 plus 1, sorry, we are starting from the complement. 1 plus here where 0 bar is 1. After that, you know that 1 plus 1, it is 1, right? Here dot 1 plus 1, it is 1. 1 dot 1, it is what? 1. And this one. The second case, 1 plus 0, 1 plus 0, 0 bar, right? 0 bar, 1 plus 0, and 0 bar plus 1. Okay, start from the complements. Okay, keep the other as it is first. 1 plus 0 bar is 1. 1 plus 0 and 0 bar is 1. 1 plus 1. And you know that this is O. O means if 1 is okay, it is true. 1 dot 1 plus 1 is 1. Here's what? 1 plus 0 is 1. 1 plus 1 is also 1. So this is what? 1 dot 1, it is 1, 1, and this 1. Okay, you can say that this is 4 inputs, and you can say it is as 1, or you can 2 by 2 also you can say. So this is after getting up to here, you can say this is answer is 1. Okay, that's the end of this lesson. Okay, that is not pretty easy part. Okay, Boolean algebra, finding the value and the duality.